Good morning, sir.
Around that central atom valence electrons, monovalent atom, bivalent atom, in the particular based on that Vesper theory, we used to find out hybridization, bond pairs, lone pairs, shape and bond angle. I will use some trick. So in that procedure, type 1, central atom surrounded by monovalent atoms only. Central atoms surrounded by monovalent atoms only. Examples: CH4, CCl4, NH3, PCl3, PCl5, H2O, BeCl2, BCl3, XeF2, XeF4, XeF6, IF5, IF7, etc. I will use one example in the given NH3. To find out hybridization, bond pairs, lone pairs, shape and type of the compound one by one. First, in NH3, N is the central atom. H is monovalent atom. For example, nitrogen valence electrons are 5 and the electrons are, I use it to write like a cross. H is the monovalent atom. For each hydrogen, one electron participate in the hybridization or participated in that bond formation because the particular hydrogen valence electron only 1. Because it is monovalent atom, for each atom one electron only involved in that bond formation of a particular hydrogen. So this N2H1 bond pair is there. Here this electron to this electron one bond pair is there. This electron to this electron one bond pair is there. 3 bond pairs, 1 lone pair. 3 bond pairs and 1 lone pair. Hybridization. 3 plus 1, 4. 3 plus 1, 4. That 4 indicates sp3 hybridization. 3 is here 3 bond pairs, 1 is here 1 lone pair. Already I used earlier, bond pairs plus lone pair sum only should be equals to hybridization. 3 bond pairs and 1 lone pair, you get sp3 hybridization. According to that Vesper theory, bond pairs and lone pairs repulsions, shape of the molecule is changed. Here 3 bond pairs and 1 lone pair, the shape is pyramidal. Type of the compound, A is the central atom, B3 is 3 bond pairs, E means one lone pair. A is the central atom. B, 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 here one lone pair. This is the lone pair only. So 3 bond pairs and 1 lone pair. The shape or geometry is pyramidal. So like this, all the examples we need to do, we get hybridization and shape, bond pairs and lone pairs and type of the compound. Type 2, central atom, surrounded by bivalent atoms only in this type. So C is the central atom bonded with oxygen, CO2, SO2, SO3, XeO3, XeO4, etc. The particular compounds is used because oxygen is the bivalent atom bonded with central atom. Oxygen is the bivalent atom bonded with central atom sulfur. Oxygen bivalent atom bonded with central atom xenon. Like that only, I used to find out like hybridization and everything in the particular SO2 molecule. Here, S is the central atom and oxygen is bivalent atom. Central atom valence electrons, it is 6th group element or 16th group element or 6th A group element. This sulfur valence electrons 1, 2, 3, 4, 5, 6. Oxygen is the bivalent atom. For oxygen 2 electrons, we use it to participate in that particular bond formation. Because here 2 oxygens are there, 4 electrons are there here. So, but 2 bonds we consider like one bond pair, that is one sigma bond, other one is pi bond. So these 2 only we consider in that bivalent atom one bond pair. This is one lone pair. So already we decided hybridization should be equals to bond pair plus lone pair sum 1 plus 1, 2 bond pairs, 1 lone pair, 2 plus 1, 3 means sp2 hybridization. sp2 hybridization. And shape is angular. Type of the compound, A is the central atom, 2 bond pairs are there here, AB2, 1 lone pair is there here, E. A is the central atom, B and B, here 1 lone pair, that is the example SO2, sulfur, double bond, it is bivalent atom, it has 1 lone pair. This is the angular geometry and it has 2 bond pairs, it has 1 lone pair and the hybridization is sp2. Type 3. Central atom, surrounded by monovalent as well as bivalent atoms only. Central atom surrounded by monovalent as well as bivalent atoms only. POCl3, SOCl2, XeOF4, XeO2F2, COCl2, etc. So we use it to find out hybridization, bond pairs, lone pairs, and everything for this example. XeOF4. In that XeOF4, xenon central atom, O is bivalent atom, F is monovalent atom. Xe is the central atom. Here central atom valence electrons are 8. 1, 2, 3, 4, 5, 6, 7, 8. So the particular 8 electrons we indicated by like cross. Oxygen is the bivalent atom. So for each bivalent atom we used 2 electrons, that is 1 bond pair. F is monovalent atom. Each monovalent atom we used 1 electron, but because here 4 monovalent atoms are there, now we used 4 electrons from 4 fluorines. This is 1 bond pair, 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 4 bond pairs and 1 lone pair. Finally, we did hybridization equals to bond pair plus lone pairs sum. Here bond pairs 4 and 1, that is 5, and 1 lone pair 1, 5 plus 1, 6, that is sp3 D2 hybridization. sp3 D2 hybridization. And the next one is shape is square pyramidal. Type of the compound, A is the central atom, 5 bond pairs AB5, 1 lone pair AB5E, and the geometry here 1 lone pair, 5 bond pairs are attached like this. The geometry only we called square pyramidal. So these 3 types are very useful. The remaining 1 or 2 types like either positive or negative species are present in that particular compound. We used to find out like hybridization. If positive charge is there, we need to remove electron from the central atom. Then you get the same procedure. If negative charge is there, gain of 1 electron. If minus is there, gain of 1 electrons to the central atom. If minus 2 is there, gain of 2 electrons on the central atom. Like that, gain of valence electrons. So that remaining procedure also same. So these types are very used to find quick hybridization and bond pairs and lone pairs and shape of the molecule. Thank you.